And here we are going to start from electron affinity. What is the definition? We first look at the equation. What you have to take note of is that before you add the electron, the atom must be in gaseous state. So the atom or the ion must be in gaseous state, and that is the same case for ionization energy. So electron affinity, it is the energy change that occurs, or the heat change, or the enthalpy change. They still mean the same thing. The energy change that occurs when 1 mole of atoms, 1 mole of gaseous atoms or ions gain 1 mole of electrons, or gain an electron. In some other books, they will say it is the energy change that occurs when 1 mole of electrons is added to 1 mole of gaseous atoms, but they are still the same. They still mean the same thing. So the definition for ionization energy, it is 1 mole of electrons is removed from 1 mole of gaseous atoms to form a positively charged gaseous ion. And for electron affinity, instead, the electron is added. So electron affinity, it is the enthalpy change or the energy change that occurs when 1 mole of gaseous atoms or ions gains 1 mole of electrons. Now, if the question is defined, then you can stop here, because the definition will give it 1 mark. But if the question says explain or state what is meant by the term electron affinity, then go ahead and show the equation to demonstrate your answer. And you know, when an atom gains electrons, it gets a negative charge. When an atom loses electrons, positive charge. When it gains electron, negative charge. So at the end of it all, for electron affinity, the charge must be negative. But remember, remember that the atom or the ion to which the electron is being added must be in gaseous state. It must be in gaseous state. Likewise, the ion that is formed. Now, this is very important. In case you photocopy your notes, you need to underline this. The first electron affinity of the element is always exothermic. And when I say exothermic, it means it gives out heat. By the way, this is the definition of electron affinity, but you know the question can say define first electron affinity. So first electron affinity, just like first ionization energy, first electron affinity is when the electron is added to the gaseous atom. With the first electron added, it is for first electron affinity. So first electron affinity, the electron is added to the gaseous atom to form a gaseous ion with a single charge, a single negatively, okay, a single, we can say a single negatively charged ion. So this is first electron affinity. Now for second electron affinity, I will have this gaseous ion that has been formed. Then it will also gain another electron, but now the negative charges will be 2. But that does not happen for chlorine. It happens for other atoms like oxygen. Remember, oxygen has 2 negative charges. So oxygen has second electron affinity, but chlorine has only 1 electron affinity because it gains 1 electron to have a stable electronic structure. So the first electron affinity for most elements is exothermic, or it is negative, or when it takes place, heat energy is given out, while the second electron affinity is endothermic, or positive. And we are explaining that. Now, electron affinity, we have said it is the energy change when one mole of gaseous atoms gain electrons. If we look at an atom with a nucleus that is positively charged, so that atom can attract the first electron with ease. So little energy is required for an electron, for the first electron to be added to the atom. But when that atom has gained the first electron, then the incoming electron, remember all the electrons are negatively charged, so the incoming electron is going to be repelled by the already exiting electron that was attracted. So for second electron affinity, we need a lot of energy for that electron to be added. So energy is required for that electron to be added. So for first electron affinity, energy is given out. For second electron affinity, energy is required to add the second electron, because there is repulsion between the first electron and the second electron. Remember, all of them are negatively charged. So the second incoming electron is repelled. The second incoming electron is repelled. So a lot of energy is required for that electron to be added, the second one. So we usually ask that for you to explain. We say explain why the first electron affinity of oxygen, for example, is negative, while the second electron affinity is positive. And we are explaining it here, saying the electron affinity, the first electron affinity, is exothermic because an electron is added to a neutral atom. An electron is added to a neutral atom containing the same number of protons and electrons. A neutral atom, that's what we mean. It contains the same number of protons and electrons. So there is little repulsive force. This is very important. There is little repulsive force, or that electron is not highly repelled. So the effective nuclear charge is high, and the incoming electron is firmly held by the nucleus. I think you know what effective nuclear charge is. Effective nuclear charge is the resultant of the nuclear charge and screening effect. I think you know those terms. Nuclear charge is the attraction of the nucleus for the incoming electrons. Then, by the way, in case you get a question on the way, you just pause me, then you ask that question in case something is not clear. Then, screening effect, it is where the outermost electrons are shielded from the nuclear attraction by the electrons in the innermost energy levels. So the electrons in the outermost energy levels are shielded from the nuclear attraction by the inner energy levels. So that is screening effect. So effective nuclear charge is the resultant, or the difference between the nuclear attraction and the screening effect. So the effective nuclear charge is high. When I say effective nuclear charge is high, it means here nuclear charge is greater than the screening effect. Or the nuclear attraction is greater than the screening effect. So if the effective nuclear charge is high, then the incoming electron is firmly held by the nucleus. So energy is released as that electron is added. Now, the negatively charged ion produced when an electron is added, we form a negatively charged ion. So the negatively charged ion produced repels further electrons because it is negatively charged, so it will repel addition of other electrons. To repel addition of other electrons. So the addition of second electron is resisted and energy must be applied to effect the reaction. And that is the reason why the second electron affinity is negative. I mean the second electron affinity is positive, whereas the first electron affinity is negative. We shall use Born-Haber cycle in physical chemistry for the topic of thermochemistry. So I don't know if that is okay. Is that okay?
Yeah, it is.
Okay.
Yes.
Okay. So factors that affect the magnitude of electron affinity. We have atomic radius, and that one I think you will agree with me that the electron affinity decreases with increase in atomic radius. What does that mean? When atomic radius increases, that means the size of the atom has increased. When atomic radius increases, then the energy level is, okay, the size of the atom is big. That means the incoming electron experiences little nuclear attraction, or the nuclear attraction for the incoming electron is less. Why is it less? Because the size of the atom is big. Remember, the coming electron is added to the outermost energy level first. It is added to the outermost energy level. So when the size of the atom or the atomic radius increases, then that electron experiences little nuclear attraction. And maybe why does an electron, what do we mean by nuclear attraction for electrons? Remember, in a neutral atom, the nucleus contains protons which are positively charged and neutrons which are negatively charged. So the nucleus is usually positively charged because it contains protons which are positively charged and neutrons which are neutral, which have no charge. So the nucleus will always attract the electron that is negatively charged. So this one should be clear to you. Electron affinity decreases with increase in atomic radius. The gained electrons are far from the nucleus and experience less attraction. I think you agree with that. Effective nuclear charge. That one you agree with me that the greater the effective nuclear charge, then the higher the electron affinity. So it will attract electrons easily. Variation of electron affinity across across period theory. Now, usually the way we ask these questions, we shall draw for you that table. We may ask you to plot the graph and then you explain your graph. So, or in paper one, we may draw for you that table. We may give you that table with that information, and we ask you to explain the trend of electron affinity. Now, I want to begin by saying, if I had said explain the trend of electron affinity here, how would you answer that? You first look at this. Now this is across the period. We have down the group and across the period. Across the period, you know what it means. It is going to the right. So if I say you first state the trend and then you explain. So you realize the trend from sodium to chlorine is electron affinity increasing or it is decreasing? That is the question you ask yourself. So for me, what I'm seeing, generally, the electron affinity is increasing. Now, don't be surprised by the negative. It means this is first electron affinity or addition of first electron. The negative means that the enthalpy change is just exothermic. So the magnitude, when we are explaining the magnitude, not the negative charge. Here, people usually get problems. They confuse chemistry with mathematics. So magnitude, when we look at magnitude, we explain the magnitude of the negative. That's why we are saying electron affinity is increasing. Although when you look at it in the mathematical point of view, -20 and -30, we say -20 is greater than -30. So we would say that the electron affinity is decreasing, but that's not the case. The case is the magnitude of electron affinity is increasing. So we don't look at the negative, we explain the magnitude. That's why we are telling you here, the negative symbol implies an exothermic reaction. That's all. It has nothing to do with the value of electron affinity. And the positive symbol implies an endothermic reaction. So the trend. Remember, that will be the question. Now, I want to add something. For you, when you are explaining, don't say electron affinity increases across the period. This answer is no longer accepted. You say electron affinity increases across the period from, I'm adding it in my notes, from sodium to chlorine. From sodium to chlorine. In chemistry, you have to be very specific, especially in paper 1. So electron affinity increases across the period from sodium to chlorine in the periodic table. So that now there I have just stated the trend. I've now stated the trend, but I need to explain the trend. How should I explain? Why is the electron affinity increases? Why is the electron affinity increasing? Now, you agree with me, the same explanation you used for ionization energy, you agree with me that as you go across the period from one element to another, from one element to another, there is an extra electron added, but that electron is added to the same energy level, because in one period those elements have the same energy, the same number of energy levels. But from one element to another, there is an extra electron added. But that electron is added to the already existing energy level. So what happens when an extra electron is added? It experiences greater nuclear attraction, because I told you the nucleus is interested in what? In electrons. So when an extra electron is added to the already existing energy level, in this case, the nuclear attraction increases and it outweighs, or it becomes greater than the screening effect. So we are saying across the period, effective nuclear charge increases, or there is increase in nuclear charge. Now, when I say effective nuclear charge increases, I mean the nuclear attraction is greater than the screening effect. Actually, both the nuclear charge and the screening effect increase. Why does the nuclear charge increase? The nuclear charge increases because the number of electrons are increasing, and you know the number of electrons in a neutral atom are equal to the number of protons. When you look at this, for example, in our O level, you remember that sodium now has 11 protons, neutral atom, but magnesium has 11 protons. So the nuclear charge increases, but also the screening effect does what? Increases. But the increase in screening, I mean in nuclear charge, outweighs the increase in screening effect. So the effective nuclear charge increases, or the increase in nuclear charge outweighs or is greater than the increase in screening effect. Since, you must mention this, since the electrons are added to the same energy level. So the nuclear attraction for the incoming electrons increases. So from what are we taking from here? Why is there a general increase in electron affinity? The effective nuclear charge increases, or the increase or the nuclear charge outweighs the screening effect. Why is that possible? Because the electrons are added to the same energy level. The nuclear attraction for incoming electrons increases. Across the period, atomic radius decreases. That one you agree with me. And if atomic radius decreases, then it means the incoming electrons are near the nucleus and they experience strong nuclear attraction. However, if we go back to when you are explaining, you must talk about these anomalies. We call them anomalies in chemistry, which are exceptional values from the trend. You see, all these values are negative, meaning energy is given out. But for magnesium, it is positive, meaning energy is absorbed. Now look at phosphorus. Whereas the magnitude is increasing, for phosphorus it has decreased. Now I want to tell you something. The sure way of explaining these anomalies is by writing the electronic configuration. I am sure you know how to write the electronic configuration. If you don't know, after here, inbox me. I have a simpler way of writing electronic configuration that will help you. Now, when you write the electronic configuration of magnesium, I want you to do that for me there where you are. Write the electronic configuration of magnesium and phosphorus. Then you should remember that atoms which have outermost energy levels fully filled with electrons or half filled with electrons, those atoms are stable and they always resist either removal or addition of an extra electron. I repeat, atoms which have a fully filled energy level, outermost energy level, or half filled energy level, they resist addition of an extra electron because they are stable. When it has the outermost energy level fully filled with electrons, that atom is stable. When it is half filled with electrons, that atom is thermodynamically stable. So it resists addition of an electron. What do I mean fully filled with electrons? You know that the s orbital or the s energy level takes a maximum of 2 electrons. The p orbital takes a maximum of 6. So it is half filled when it has 3 electrons. Then the d orbital takes a maximum of 10, and it is half filled when it has 5. And the f takes a maximum of 14, and it is half filled when it has 7. I don't know if you have written the electronic configurations. then you will be able to understand what I'm talking about. So the electron affinity for magnesium is endothermic. We are still explaining is endothermic process because an electron is added to full 3s orbital. That means when you write the electronic configuration, the outermost orbital will be 3s sub-energy level. That is thermodynamically stable. All these are half max and resists addition of an electron. Hence, energy is absorbed to effect addition of the electron, or energy must be absorbed to add that electron. The electron affinity of phosphorus, as you can see, the electron affinity of phosphorus is less exothermic process. It is less exothermic compared to the others, because an electron is added to a half field. That means when you write the electronic configuration for phosphorus, this must be 3p3 sub-energy level, that is thermodynamically stable and resists the addition of an electron. Before I move on, unmute and tell me if there is something that is not clear to you and I talk about it. I want to give you the time. This is the basis of inorganic chemistry. If you don't understand these things when you are in senior 5, you may never understand them. Nabuma.
Yes, teacher.
I want questions. If things are clear, you tell me, I proceed. Rosette, what do you say?
Tell me I'm fine.
Okay. So variation of electron affinity across, this should be down the group.
I'm still trying to process these things since I came in a little later. So.
Yeah, you are trying to process.
Yeah.
Did you get the notes? For you first to understand, then you look through the notes later. Okay? Because I sent notes on the page. You understand? So variation of electron affinity down the group. Here we have fluorine. We have, so please, we have down the group and across the period. Yeah? Now all these atoms are group 7 elements. They are all group 7 elements. So down the group, but electron affinity generally decreases down the group. You agree with me? The magnitude is decreasing. Both nuclear charge and screening effect increase down the group, but the increase in screening effect outweighs the increase in nuclear charge. So in other words, the effective nuclear charge here decreases. Why does screening effect outweigh nuclear charge in this case? Remember, as you go down the group from one atom to another, from chlorine to chlorine, and from chlorine to bromine, there is an extra energy level that is added. You agree with me? There is an extra energy level that is added, but the number of electrons do not change in the outermost energy level. So all these atoms here, for example, if you use your O-level knowledge and you look at fluorine and chlorine, you will realize that they all have 7 electrons in the outermost energy level. So from one element to another, there is an extra energy level that is added, but the number of electrons do not change. So what happens, and the extra energy level that is added will lead to the added electrons in the other extra energy level will be screened from nuclear attraction, or will be shielded from nuclear attraction by the innermost energy levels, because you are adding energy levels and you are not, and the number of electrons remain unchanged. So from element to element, a full energy level or sub-energy level is added. So when it is added, the atomic radius increases. When another energy level is added, the atomic radius does what? Increases. So effective nuclear charge decreases, the ability to attract electrons decreases. So the ability of the nucleus to attract electrons does what? Decreases. So so that's why electron affinity decreases from fluorine to chlorine. And again, we are saying the electron affinity of fluorine is less than expected because fluorine is a small atom. So it being the first one in the group, it means it has the smallest size. It has the smallest size of the atom. Fluorine is has a small atomic radius. The electron affinity of fluorine is less than expected because of the small atomic radius of fluorine. So the lone pair of electrons on fluorine, they repel the incoming electrons. And that is it for electron affinity down the group. So electron affinity, or the ability of an electron to be added to an atom, decreases down the group because the effective nuclear charge decreases, or the screening effect outweighs the nuclear charge. Why does that happen? Because from one element to another, there is an extra energy level that is added, but the number of electrons remain the same in the outermost energy level. So they screen each other. So the outermost electrons are shielded from the nuclear attraction, and also atomic radius decreases. Then for chlorine, its electron affinity is very small compared to the others, because it has a small atom and a small atomic radius. So the lone pairs of electrons of chlorine repel the incoming electrons. I don't know if you have something to say there, or we continue. Continue? Is it okay?
Yes.
Okay, electron affinity. I mean electronegativity. Electronegativity, it is the tendency. Let's say I have an atom like hydrochloric acid. Now in hydrochloric acid, you know chlorine atom is negatively charged or has a partial negative charge, then hydrogen atom is positively charged. So the tendency of chlorine atom that is negatively charged to attract the bonding electrons, the electrons between hydrogen and chlorine bond. When chlorine attracts those electrons towards itself, that's what we call electronegativity. So electronegativity is the tendency of an atom in a molecule to attract bonding electrons. This word must be there. Don't say electrons only. To attract bonding electrons towards itself in a covalent bond. That is only possible if you have a covalent bond. And in a covalent bond, it is formed by sharing of what? Electrons. So when the chlorine atom attracts the bonding electrons from the hydrogen chlorine bond. Now the electrons are going to be unequally shared. That means chlorine will take all of them, so it will get a negative charge, and hydrogen, which has lost its electron, will get a positive charge. So electronegativity, the definition, it is the tendency of an atom in a molecule to attract the bonding electrons towards itself in a covalent bond. Stop here. Fluorine atom is the most electronegative element. Electronegativity. Fluorine atom is the most electronegative element, and we are saying electronegativity is not measured directly. It is given an arbitrary value. Factors that affect electronegativity or that affect an atom to attract the electrons. We have atomic radius. Yeah? So the smaller the atomic radius, that means the electrons in the outermost energy level, the electrons will be near the nucleus. So they will easily be attracted. So the smaller the atomic radius, the greater the electronegativity. That one you agree with it. And effective nuclear charge. If the effective nuclear charge is high, then the atom will have a high electronegativity. So again, I have the table. Like I told you, we may give you this table and we ask you to explain the trend of electronegativity. And you can see from sodium to chlorine, this is across the period. Electronegativity increases across the period. I told you add from sodium to chlorine. Across the period, both nuclear charge and screening effect increase, but across the period, nuclear charge, the increase in nuclear charge is greater than the increase in screening effect. Why? Because from one atom to another, electrons are added, an extra electron is added, but energy levels don't change. So an electron is added to the already existing what? Energy level. So the electrons screen each other poorly because the energy levels have not changed. So that's the screening effect factor is less than the nuclear charge factor. So the nuclear charge outweighs the screening effect, and so atomic radius decreases. So atomic radius decreases when the nuclear charge outweighs the screening effect. That means electrons are strongly attracted to the nucleus and the atom will form a small size. So the ease with which atoms attract electrons increases. I think you have understood that. And let's look at variation down the group. Down the group, we have sodium. No, this is not down the group. This is the same thing. This is an assignment. Okay, but down the group, what would we expect for electronegativity? Down the group, from fluorine to chlorine, the electronegativity is decreasing down the group. Both nuclear charge and screening effect increase, but increase in screening effect outweighs increase in nuclear charge. Why? Because from one atom to another, an extra energy level is added, but the electrons remain the same. So they will screen each other properly, and the screening effect outweighs nuclear charge, and the atomic radius increases, and effective nuclear charge decreases. So the ability to attract electrons also does what? Decreases. Now, this is an assignment and it is about electronegativity. We can ask you to explain the trend of electronegativity. Define the term electronegativity. Plot the graph of electronegativity versus atomic number. I think you are going to plot this graph in your free time. Then you explain the shape of the graph. Electropositivity. What do you understand by the term electropositivity? Electropositivity is the opposite of electronegativity, whereas electronegativity is the ability of the atom to attract electrons towards itself. For electropositivity, it is the ease with which an atom gives away its electron, or donates electron, or loses electron. So electropositivity is the ease or tendency of atoms of elements to lose an electron or electrons from the outermost energy level for a positively charged ion. Factors that affect electropositivity are, of course, we have atomic radius. When atomic radius is big, when atomic radius is high, I think you know the definition of atomic radius. It is half the internuclear distance between two atoms in a bonding situation. So when atomic radius is high, that means the electrons are far away from the nucleus. So they experience less nuclear attraction. So the electron can easily be lost. So the bigger the atomic radius, the greater the electropositivity. The outermost electrons are far from the nucleus, This should be nucleus. Are far from the nucleus. Are far from the nucleus and experience little nuclear or less nuclear attraction. Less energy is used to remove the electron. That one you agree. Nuclear charge, the lower the nuclear charge, the greater the electropositivity. That one nothing to explain. Then ionization energy, the lower the ionization energy, the greater the electropositivity. Electropositivity decreases across the period, i.e., across the period, the electronegativity decreases. I think you know the reason, because across the period, the atomic radius decreases. Atomic radius decreases, so the electrons are near the nucleus, so they experience great nuclear attraction. So it requires a lot of energy to remove an electron which is experiencing nuclear attraction. Ionization energy increases because across the period, both nuclear charge and screening effect increase. Electrons are added to the same energy level. They screen each other poorly. This is just explaining why electropositivity increases across the period. The increase in nuclear charge outweighs the screening effect, or the effective nuclear charge increases instead of this. Atomic radius decreases and electrons are held strongly to the nucleus. More energy is required to remove the electrons. Then variation down the group. Electropositivity increases down the group Because down the group, you know, atomic radius increases as atomic size increases, and the screening effect outweighs the nuclear charge, or the effective nuclear charge decreases. So this one is clear. I want us to stop here. Maybe next time we shall see what to do, whether to start from melting point. But I'm going to get for you a question to try out. So I now give you the chance